I'm John Gastineau, staff scientist and physicist with Vernier Software and Technology. I'm going to show you one of the experiments from the Nuclear Radiation with Vernier book. This is a very short book. It just has 6 activities in it. It can be used either with a chemistry or physics laboratory course. The activity I'm going to show you is the counting statistics activity. Nuclear counting statistics can be described either by Poisson or Gaussian statistics, depending on the number of counts per unit time. So I'm going to take a strontium-90 source and put it right up against the Geiger tube in a Vernier radiation monitor. Now, I've already done some setup in Logger Pro. I'll go through how that setup is done in just a little bit. I have chosen a count interval so that, on average, only 1 or 2 decays are captured during any single count interval. And if I take data, I see 2 graphs. One is the number of counts per unit interval as a function of time, and you see that's just kind of a noisy number. It's a small number, 0, 1, 2, something like that. The lower graph is a histogram of those counts per time interval. And you can see in the left-hand bar is the 0 count bar. That shows that some of the time there are no counts at all during a time interval. The most common result is to have 1 count during a time interval. I end up with a distribution that is asymmetric. This is a Poisson distribution. Now, I can change my count interval so that the number of counts during one interval is instead about 15 or 20. And if I do that, the counting statistics will be described well by Gaussian statistics. So I'm going to go in and change my count interval. You can see here that it had been set down to about 2 milliseconds. I'm going to change that to 30 milliseconds. And I'm going to click Done, and I'm going to clear my old data here and take a fresh run. This time, the average number of counts in a time interval is approximately 16 or 17, and my distribution of counts is symmetric, and the shape of it is very much that of a Gaussian. The longer I take data, the more closely that approximates a Gaussian. Now, I took data all night last night to show what it would look like if we counted for over 40,000 time intervals. Let me show you what that one looks like. And the graph at the bottom of the screen is a histogram of the count frequency. The average number of counts in an interval in this case was up around 570, but you can see the shape of the distribution is that of a Gaussian. The black line is a Gaussian curve fit that I have applied in Logger Pro, also showing that this distribution approximates a Gaussian. So let me show you how I set this up. This is my strontium-90 source. I'm going to need to put that back by the radiation monitor, but I have a Vernier radiation monitor. It's a simple Geiger tube. I've got that connected to the digital port on Vernier LabQuest Mini. I could also use a LabQuest 2. I'm running Logger Pro on my computer, and I'm going to open a file that is included with Logger Pro for the counting statistics activity in the Nuclear Radiation with Vernier book. So let me open that file. The first thing I need to do to conduct this experiment is to find a time interval in which I get, on average, only about 1 or 2 counts. To set that time interval, I need to measure the average rate of my radioactive source. So I'm going to put that right next to the radiation monitor. And this file is set up to take data once every second, and it gives me then the number of counts in a 1-second interval. And I can see, looking at my screen, that my average number of counts is somewhere just over 500 counts in a 1 second interval. That means that if I were to use a 2 millisecond count interval, I should on average get about 1 count. I think when I'll do this experiment, I'll set it up to use 3 milliseconds, so I'll get an average just over 1 count per interval. To do that, I'm going to go to my data collection dialog. That is the icon right next to the collect button that looks like a stopwatch. And you can see the seconds per sample setting is currently set to 1 second. I'm going to change that to 0.003 or 3 milliseconds and tap OK. Let me clear the data here, and I'll start taking data again. This time, my count intervals are very short, just 3 milliseconds long, and so I've got a lot of them going past. And you see that nice Poisson distribution growing in the histogram. To collect the Gaussian distribution, I need to increase the duration of the count interval to get an average count rate of something more than 15. So to do that, let me stop that and go back to the seconds per sample field, and let me change that. Let's see, my average was here was a little over 2, so let me just multiply that by 10. So I'll go set it to 0.03 and clear data. So now I'll collect data using this longer time interval with the higher average number of counts per time interval. The distribution of the counts per time interval follows a Gaussian distribution. So that's all there is to studying counting statistics using a vernier radiation monitor and Logger Pro. For more information on this activity or any of the other activities in nuclear radiation with vernier, check out the Vernier website.